Oh, I'm delighted to report what I think is the first convolutional neural net in Excel with backprop. It's a single-digit classifier, been running for a while to train up this set of data, and it's remarkably good. I'm not looking at the full NMIS digit set of 60,000. I'm just looking at 10,000 at the moment, so it's overlearned it, but I was trying to build quickly. So this is built looking at the data set that we've got. You've got an initial 4 filters that are scanning over these images as seen by the computer and seen in a 28 by 28 matrix, and you're seeing the results of these filters and the features that it's picking up. It could be vertical, horizontal edges. I mean, I don't know, because it's training itself, which is really the exciting thing. I'll kill the code there and show you a bit more about what it does. Okay, so first filters, going to the Z and then to the non-linear bit. You can see the ghostly images within them now. And then we move on to the second set of filters, which I've got 8, but each one has got 4 channels, if you like, or a depth of 4. And to backprop this, I needed to pad and then rotate these to get the back propagation to work, which is reasonably difficult to find any information on that. So it's a bit of a bodge job, and I would suspect that this beautiful neural network's fairly dyslexic in the way that it works, rather like its creator. So there's huge room to optimize it as I figure out what's going on. There's also massive room to improve it with with optimization, etc. Because after the second convolutional layer, we go into a fully connected layer 2, 15 neurons, and then we've got 10 neurons with the final softmax function at the end that's looking at that. There's a couple of rows hidden here, but you can't really see much of what's going on. So if I initialize this, and that's resetting all of the parts of the brain, if you like, the filters and the fully connected filters to an initialization parameters, which are a bit tricky to find, then you get absolute rubbish. So we've got 2%, so it's just not finding anything. And it takes a while to get it up. I'm improving the speed. A batch run will improve it, as in we run more than 1 digit at a time. But if we escape from that code again, and I'm going to reset it, and I'm going to load back the best data that I've got so far and learn from here. This was the result of not that many runs, I think about 100,000 or so, and unfortunately my count is slightly wrong, so it's saying it's over 100% correct, but it's pretty high up there. In fact, we're seeing all of the recognition presented to the computer versus what we see as a 1, so it's looking good. Look, if anybody's interested in neural networks and convolutional neural networks in particular in Excel, please comment. I'd be interested to talk about how it was built and areas that it could be improved. It's learned the data set fairly well, I think you would agree. Good grief. That's 100%, I hadn't realized that. So it appears that even though we get very few parameters effectively, and those parameters are shared, as in the way convolution works, they've been sufficient within a couple of 100,000 or 100,000 iterations to learn the data set of 10,000 digits so well that we're getting recognition right up at 98, 100%. Of course, the test would be to run these on digits that it hasn't seen, but at this stage, I built this last night, or I finished at about 2 in the morning, and I was delighted to see that it even worked. So there you go, convolutional neural network in Excel with entirely on-sheet based calculations. The VBA is simply stamping an update onto these blue numbers. There you go.